Well, believe it or not, we've already made it to problem set number 8. Polar functions and parametric functions. So of course, I'm going to change it just slightly. The one that I gave you is sine of 2 theta. I'm going to change it to cosine of 3 theta. The work is pretty much the same. First of all, graph it. So try to get the glare off the calculator. There we go. And if you haven't already, go to mode and change it to polar. So hit enter. And also make sure that it's in radians mode. Then second quit. And now when you go to y equals, it's actually going to say r equals. So cosine of 3 theta. And then go to the window. And I'm going to start by having it go from 0 to 2 pi. And then if this says 0.13, change it to a 0.03. That will make a more accurate graph. And also x can range between -1 and 1, and y can range between -1 and 1. Because the biggest that cosine ever gets is 1, so it ranges between -1 and 1. And then take a look at the graph. So there's one branch of it, or one petal of it, right here. There's another petal right here, and there's another petal there. Okay, so that's graphing it. Find all the values where r equals 0. Well, r equals 0 means the origin. So what values of theta would make it go through the origin? So you just set it equal to 0. And then you can think about the regular cosine graph, which looks like this, from 0 to 2 pi. And then it's going to equal 0 right here, and it's going to equal 0 right here. So this would be at pi over 2, and this would be at 3 pi over 2. Let's see, it started right here, and then it went something like this. So it went 1, 2, 3. It looks like I probably need 3 answers. So if you continue the graph out, there's going to be another answer right here. This is 1 pi over 2, 3 pi over 2, so the next one is 5 pi over 2. Now I need to set 3 theta equal to each one of these. So 3 theta equals pi over 2. 3 theta equals 3 pi over 2, and 3 theta equals 5 pi over 2. Then the next thing to do is use a red pen and divide by 3 on both sides. Oops, I just dropped the red pen. So then theta equals, this will be pi over 6. The next one will be 3 pi over 6. So actually that reduces to be pi over 2. And then 5 pi over 6. And then I want to check those answers. So when I put them in the calculator, it should give me the origin. That's where r equals 0. So let's see if I got those right, but without the glare. So just go to trace and then try pi over 6. And the cursor is in the origin, so that's good. How about pi divided by 2? Yes, that's correct. And 5 pi divided by 6 should be at the origin. Right on. Now, find values that will give you just one petal. Okay, so one way to do it is just play with the calculator. So you could change the window and go, how about 0 to pi? That is way too much. In fact, that's the whole graph. And I want 1/3 of that. So how about if I go from 0 to, instead of pi, 1/3 of pi? Does that make it? Oh, so close. So it gave me half of a petal and half of a petal, but it didn't give me a whole petal. Well, notice that right here, this is when r equals 0. So at some point r equals 0. So by some point, I mean one of these things down here. And then it's going to go around and create one petal. So I believe that if I put these two, that it's going to create one petal. So instead of guessing and checking, try that. Pi divided by 6 to pi divided by 2. Sure enough, that works. And if I would have chose this one and this one, it should work also. It should give me a different petal. Pi divided by 2 to 5 pi divided by 6. So there's another possible answer. Now there's this little gap right here, but that's just the calculator making a small mistake. If I change this step to be something even smaller, then it's going to graph it more slowly, but then there's no gap. Okay, so for one petal, like this petal was pi over 6 to pi over 2. Next up, how about an example like number 2? Except I'm going to change the functions just slightly. So take a look at these graphs. Clear that one out. Goes sine of theta and then sine of 2 theta. And then have the window go from 0 to 2 pi. I'm going to change this back to like 0.03 and then go to the graph. So one function, like the red one, has 1, 2, 3, 4 branches. And the other one, that's where I need my red pen back. The other one goes like this. And it looks like they intersect in 1, 2, 3 places. But let's see what the math says. Do they actually intersect in 3 places? So you set them equal to each other. And then for this particular one, I'm going to need to use a trig identity on the right side. That's equal to 2 times sine theta times cosine theta. And then what I could do is subtract sine theta to move it to the other side and have it set equal to 0. So subtract sine of theta. And then sine of theta is showing up in these 2 places. That means that I can factor it out. And it would leave 2 cosine theta minus 1. And then set them equal to 0. So it's either that sine of theta equals 0 or it's that 2 cosine of theta minus 1 is equal to 0. With this one, I could add the 1 to the other side, and then I could divide both sides by 2. So this one says, when does sine equal 0? And if you look at the sine graph, there's going to be these 3 places where sine is equal to 0. That would be 0 and pi and 2 pi. All right, so there's 3 answers. And then for this one, when does cosine equal a half? So if you look at the cosine function, it looks like this from 0 to 2 pi. And 1/2 would be right here. Draw a line straight across, and there's actually 2 solutions for that. The first solution you can find by doing cosine inverse of a half. So cosine inverse of 1/2, and I believe that's pi over 3. Let me see. Divide it by pi and change that to a fraction, and it's 1/3, so it's 1/3 of pi, or pi over 3. So this one is at pi over 3. This one is to the left of 2 pi, so this one is going to be 2 pi, move to the left by subtracting pi over 3. So this, you could change it to 6 pi over 3 to get a common denominator, and so that would be 5 pi over 3. So I actually got theta equals 0, theta equals pi, theta equals 2 pi, theta equals pi over 3, theta equals 5 pi over 3. And yet, by looking at the graph, it looks like there's only 1, 2, 3 places where they intersect. So for them to intersect, they have to get to the same place at the same time. Okay, there it is. Under mode, if you change this, perhaps you already did, to simultaneous, it'll graph the two graphs at the same time. Then have the graph slow down, so make this a small number like 0.01, and then watch and see, do they get to the same place at the same time? So they started at the same place, and right there, yes. So right there, that one went through the origin, but that one did not. And then they meet at the origin. Now the blue one is drawing the blue graph for a second time. And I can't quite tell because it's drawing the blue in the blue over blue. I can't tell if they got there at the same time. So what I can do is right here, when you go to y equals, move over to where the color is, and you could leave the color, but change this to be this symbol right here. So it's a circle that leaves a line behind it. So that way it's going to draw a circle as it draws the graph, but it's going to leave the graph behind. And here as well. So just use the right arrow key to choose that. And then, okay. So now when it graphs it, you could see the two circles, and then we need to see, did the two circles get to the same place at the same time? That's a yes. That is one of the extra answers that we got that we're going to have to throw away. And it looks like they're going to get to the origin. That should be pi because it's halfway done with the graph. And then I'm wondering about this answer, 5 pi over 3. So by the time they get to right here, are they going to get to the same place at the same time? Oh no, they're going to crash. It worked. They actually did get to the same place at the same time. So I'm pretty sure that's this 5 pi over 3. Okay, so which answers do we keep? So you trace and put 0. And right now, can you see it? Right now, it's on the blue graph. And then if I put the up arrow, it says now I'm on the red graph and I'm in the same place. So that means that this answer, keep it. Then what about pi? So if you put second pi, so right now on the red graph, it's at the origin. Then put the up arrow, and I'll need to type 0 because I'll need to type pi because it changed it just slightly. And it's in the same place. So that is a keeper. And 2 pi is really the same thing as 0, so I guess technically that is true. What about pi over 3? So pi over 3, so that's that point right there, that's a keeper. and 5 pi over 3. Yep, there we go. Actually, we keep them all. All right, then for the third one, parametric. So here is a parametric function. And then let me look for the directions. So graph it, okay? So go back to mode and change the mode right here to parametric form, and then go to y equals, and let me erase this other class's problem, and 1 plus 2 sine of t is what I'm going to use. And then cosine of 2t. So it's just slightly different than the one on the problem set. And then, let's see, I'll need to change the window, go from 0 to 2 pi. And then x could get as big as 3. So I'm going to put -3 to 3. And then to be fair for the y's, I'm going to do the same thing, -3 to 3. And what does the graph look like? That looks like a parabola, or at least part of a parabola. Find all the x-intercepts. So the x-intercepts would be this one and this one. And for the x-intercepts, that means that the y value equals 0. So just take this one. So for the x-intercepts, put y equal to 0. So once again, just look at the regular graph of cosine, which looks like this. And then it equals 0 right here and right here. So this would be pi over 2, and this would be 3 pi over 2. But then you need to set 2t equal to each one of those. And then divide both sides by 2. So this one is going to become pi over 4. And this one is going to become 3 pi over 4. I was just looking at the directions and I said find the x-intercepts. So this is not the x-intercept. This is just the time when it gets to the x-intercept. Now I have to actually find it. So plug in t equals pi over 4. Trace pi over 4. So this point right here is x equals 2.414 and the y value equals 0. And then use 3 pi over 4. 3 pi divided by 4. So then this point right here is x equals, hey, that's the same point. Didn't I? Let me test again. Pi divided by 4, that's that one. 3 pi divided by 4, that's the same point. What about the next one, which would be 5 pi divided by 4? Okay, because when it drew the graph, it started and it went down this way, it hit the x-intercept, it went down, it went back, it hit the x-intercept again, and then towards the end of the interval, it finally got over here. So I would have needed to continue this graph out, and there would be another answer right here at 5 pi divided by 2, and then you put that over here, and once you divide, that would be 5 pi over 4. Okay, then that point is x equals -0.414, comma 0. There's the x-intercepts. Then for the y-intercept, so there's just one y-intercept right here. And for that, you put x equal to 0. So 0 equals 1 plus 2 sine of t. And then I could subtract 1 from both sides. Next, I could divide by 2, and then just take sine inverse of negative 1/2. Now, I think I should look at the graph, because the sine graph goes like this. When does it equal negative 1/2? Well, that would be an answer over here and an answer over here. But I have a feeling what the calculator is going to do is it's going to find the answer that's closest to the origin. So it's actually going to give me this answer right here instead of one of these two, which I want. But that's okay. If it does that, I know what to do. So right here, take sine inverse of negative 1/2. Yep, it's a negative, so it's giving me this answer. If I divide that by pi and change it to a fraction, so this answer is at negative pi over 6. In order to find this answer, which is positive, well, right here is pi, and this one is to the right of it. And it's going to be the same gap that's right here will be right here. So that means that this one is at pi plus pi over 6, or 6 pi over 6 plus pi over 6 is 7 pi over 6. Then let's see if it works. Trace and go to 7 pi over 6. Perfect. Okay, so that point is at 0, 0.5. All right, so I hope that this helps with problem set number 8. Please feel free to contact me if you need any more help.